Good morning, mathematicians. Ah, when did I start streaming? Was the semester still happening when I started streaming? I think it was, right? It was still during the winter semester. Just, yeah. Curious how things will go when the semester starts. I wonder if when I started streaming, people will show up here. Was, right? It was still during the winter semester. Ah, good morning, Daysen. First in chat. Let's get ourselves organized here. Good morning, Edit Smith. Yeah, let's see what's going on these days. You swear these keep getting earlier. Are you losing track of time? Today's earlier than the last couple ones for sure. I mean, I've had some early ones. I've had some real early ones. I've had some, well, real early ones? I don't know. 7 my time. Good morning, Nerdy Quagsire. Wow, so many people on the ball in chat today. And Ken, wow, the whole you know, the usual cast of characters is here. And Lola, good morning. Everyone's here right away. Well, not quite everyone. We're you know, there's some other, of course, a Rod, but I'm sure he'll roll up any minute now. And plenty others. Mr. L. New Wave Infantry. Wow, I actually remember people's names. People's digital names. Hello, Spaceman Matt. Welcome. Yeah, let's, I don't know. Thought maybe we could check some stuff going on in archive. As I started the stream, you're reading the fundamental theorem of Galois theory. What a beautiful thing to read. It reminded me of non-Stellensatz. Are they connected? Yes, I believe actually that so I think the general term is a Galois connection when you basically have a like a lattice, an order reversing lattice isomorphism, something like this. And yeah, so I think the general, Galois connection is just the general. Fundamental theorem is just a poset adjoint. Yes. Yeah, I think the term is Galois connection. Yeah. Two ordered posets, Galois connections, fundamental theorem of Galois theory. Yeah. Yeah, exactly. So here's the explanation in terms of adjoint pair of functors. Right. Yeah. Yeah. So it's all the same. It's all connected. Oh, here's something interesting that came up in a Discord server I hang out in. Is someone was asking about, you know, the adjunction and how far the similarities go, right? Because it's like, well, an adjoint pair of linear operators, you know, satisfies this condition, or maybe even to highlight things more. Let me write it this way. So F and G are an adjoint pair of linear operators if this is satisfied for all vectors, and likewise. F and G are an adjoint pair of functors if this property is satisfied from hello. Unfortunately, I don't know how to pronounce your name, but I've seen you here before. Welcome. And yeah, that we have an isomorphism here. So, but it's more than just a formal property, right? Because, and I do wonder in general to what sense this can be extended. Because if now we look at the categories of representations of finite groups, so we have rep H. H is a subgroup of G. And we have the induction and restriction functors. I always forget which goes on which side. It gets especially confusing because you get these like double adjunctions in my research. But anyways, you have these adjoint functors, which are both exact. And so therefore they induce a pair of linear transformations on the Grothendieck groups. And essentially because these categories, I'm thinking characteristic 0. In the characteristic 0 case, these categories are semi-simple, and in fact they define adjoint linear operators with respect to the pairing, where two well, I guess there's different ways to describe it, but basically, if you have like a pair, you pi 1, you sum this over its e reps, and you sum this over the e reps, then you basically, it'll be the sum of AI bi, or sorry, this should be alpha I, same e reps. But this is the same. This is the same for. This is same as the trace pairing. So if you take the corresponding trace characters, if you have two characters, the pairing of this character is 1 over G times the sum of chi omega bar over G and G. So same pairing. Okay, there's more to say about this, but Nerdy Quagsire, you started reading Sayre's linear representations of finite groups? Good. And you feel it's too out of your depth? How to remedy that? Well, I would also try maybe looking at Fulton and Harris's book called Representation Theory. Admittedly, I think it is fairly terse. You know, the introduction to representations of groups there is also fairly short and concise. But maybe consult that as well. And I don't know, try to write out examples of stuff as you go. So, yeah, try and write down some representations of some groups. Pick all your favorite groups and see if you can write down some representations of them. See if you can construct for every representation, if you can construct a given group. Sorry, for every group, if you can construct a representation. Yeah. So there's another there's a paper of Prasad, Dipendra Prasad, where in the if you're talking about representations of smooth representations of p-adic groups, then you have another pairing. Well, first off, we have special subgroups now called Levy subgroups. And we have a sort of special kind of, I mean, you can just think of it the same as induction and restriction, but I'll write it with a J now because it's called the Jacquet functor. Ask away at it, Smith. Oh, I gotta remember, this thing always goes top chat, and I want all messages to be visible. Now I'm worried I might have been missing so many messages over the years. Top fans, yeah. Yeah. Also, how do I? You guys gotta let me know. I was looking at making some merch, so I'm still looking into that. Basically, just gotta upload some designs and make them. So I don't know what you guys would be interested in. I was thinking, some interesting commuting diagrams on some shirts, some Riemann rock on a tote bag or something. I'd really like to have a baseball cap with a QP embroidered on it. Although, I don't know, I made a bonfire account. I don't know if they do embroidered designs. That's maybe more expensive. So I don't know where I could go through to get the embroidered designs. But yeah, I don't know. Let me know what you guys like. What is the GOATS group? Grothendieck group. And lab. I see. Sorry. Of course. I gotcha. I'll explain that in a second. Seek, you wrote your post on Stack Exchange and you got -3 because you didn't write. Yeah, so Stack Exchange, you want to format everything in LaTeX. Yeah. Well, definitely something now for next time. I don't think you lost 3 because your proof was wrong, right? It's a place to ask questions. So I don't think you got downvoted simply for having an incorrect proof. I mean, it's full of questions where people say, "Hey, what do you think of this proof?" But yeah. So let me just the Grothendieck group is basically you take your abelian category and you look at the free group. I guess, on the objects of your category, and then you mod out by the group generated by A minus B plus C for every short exact sequence ABC. So in other words, if A, B, and C fit into a short exact sequence, then in the Grothendieck group, you think of B as being A plus C. Yeah. So yeah. So for example, for the category this, by the way, was free objects? I guess I should say on the isomorphism classes. It's the free group on the isomorphism classes. So this should all be in terms of isomorphism classes. So classic example, for vector spaces, we have, there's one element. There's one element for each vector space. Let's say finite dimensional vector spaces. Then this is isomorphic to the integers. Aren't you legally obligated to say K naught and Kong Z? No, I'm not. Fight me. K naught and Z. I mean, yeah, I guess. Well, I mean, Z is like the monoid completion of N, but I don't know if I'd call it the Grothendieck group. Like, what's the category? Um, I guess the category is finite dimensional vector spaces. Yeah. But okay, there's more I want to say about my research. We got Nerdy Quagsire. How dare you say fraud and deek? You're risking a ban here, perma ban forever. Is there such a thing as a quadratic representation of a group as opposed to linear? I've never heard of such a thing, but there could be. You could invent one. It would suck though. My guess would be it would suck. The whole reason we make it linear is because like groups are hard and linear is easy. How many exercises should one do a day? Well, let's see. I'm gonna go first. I'll do biceps, and then I will do. Well, I'm gonna do sprints right after this, so that counts as an exercise. Okay, I know what you meant. I was just kidding. Like maybe 6 exercises in Hartshorn per day. You feel it's nothing? Are you sure you're doing them correctly and rigorously? Like when you say doing an exercise, you just solving it, or are you typing it up in detail? So I mean, I feel like even just solving it, yeah. How do you know that it's correct? Because 6 exercises a day from Hartshorn. Assuming you're skipping the ones that are starred as unsolved problems, is still considerable. So yeah, I don't think it's bad if you're actually doing 6, but yeah, what does it mean that you're actually doing 6? Are you writing up a really rigorous, well-written, proper proof? Yeah, 6 a day is kind of crazy. You take multiple weeks to procrastinate and do your assignments on the last day. Oh, Boris. I used to be a young man too. Now I procrastinate too sometimes. This is a great quote. I'm gonna bring it up. Never been downvoted on Stack Exchange. As long as you followed how to ask a good question instructions closely. Yes, exactly. How are you so fit? Every morning you do 50 pullbacks and 50 push forwards. Yeah. That's good. No, keep it up. You should be adding 1 to that. Progressive overload. 1 extra pullback and push forward every day. 1 exercise is enough for you, but you feel like spreading out your knowledge built on that exercise. Yeah. Any advice for someone who started math in their mid-20s and feels behind and slow compared to their peers? I don't know. Lots of people feel slow and behind compared to their peers. I would say, yeah. I don't know. I'm not gonna say don't compare yourselves to people. Of course, everyone compares themselves to themselves to other people all the time. And certainly you can't just stop that from happening. Yeah, I don't know. I mean, the only thing you can do is just keep going at your own pace. Yeah, I don't know. There's no magic speed up button. I guess you just gotta. Hey, I've known even older people, people much older than that, starting mathematics. Yeah. So. Yeah, I don't know what to say. Yeah, try not to worry too much about it. Like if you enjoy it, then you enjoy it. I don't know. But I want to read this about Boris's procrastination quote. This quote I love from Paul Halmosh. I love to do research. I want to do research. I have to do research. I hate to sit down and begin to do research. I always try to put it off as long as I can. Isn't there something I must do first? Shouldn't I sharpen my pencils, perhaps? In fact, I never use pencils, but pencil sharpening has / become the code phrase for anything that helps to postpone the pain of concentrated creative attention. It stands for reference searching in the library, systematizing old notes, or even preparing tomorrow's class lecture, with the excuse that once those things are out of the way, I'll be able to concentrate. I'll really be able to concentrate without interruption. Love it. No, just you just outline the proof and you check them online and on Stack Exchange. Okay. You don't mean exactly 6, sometimes 2 to 3, but no, you don't type them. Is just outlining proofs bad? I mean, I think, I don't know. I mean, I could see an argument for saying that outlining the proofs is better. Like once you get the idea, just go ahead and keep plowing through to learn faster. I don't know. Maybe I would be doing some crazy categorical Langland stuff now if I was doing that. Yeah, here's the thing. People always ask me for advice. I'm like, there's a lot better mathematicians out there than me. So I don't know if you guys should be taking my advice on stuff, but here we are. I'm going to give it anyways if you're going to ask it. But I don't know. I do think there is something to be said for carefully going through each detail, right? When you sketch things, I don't know, you can miss important details, and I think it's important maybe to go slow, and carefully go through these details. Writing out solutions, full solutions feels very tedious to you, but you grind it out anyways. Good, because it gives you a level of satisfaction. Yeah, and also like that's what research is. If you don't write it out, it just kind of feels like there's nothing tangible to show for your effort. Yeah, like somehow if I don't write things out properly, I feel like I didn't really understand it. Yeah, so maybe Edit Smith, try writing things out in full detail. I know it's not always the most fun, but that might help with your sense of satisfaction and sense that you learned things. Your version of pencil sharpening might be random cleaning or DIY crafts. Nice. That's some good pencil sharpening techniques. The goat's quotes are also awesome. Yeah. I've got a number of the goat's quotes here. Yeah, this is all my personal webpage. There's a bunch of there's all my favorite quotes. Yeah. Your version of pencil sharpening is math, but just not the math you need to do at that moment. Actually, very true. Very true. Very true. I mean, how do you think this channel came into existence? Yeah. The other day when I recorded the 2 things about semi-direct products, yeah. You don't think I had other much more pressing things to do, like get my paper out so that maybe someone will hire me as a postdoc this semester? Yeah. But then what did I do? I made a short about the CeeLo theorems, and I made 2 videos about semi-direct products, and I'm gonna make more soon. Can I prove projective? Paul, Maurice, you already know I can't prove anything that you ask me. You always ask me good and interesting questions, and the truth is, despite the fact that I blah 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 D modules blah 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 Riemann Hilbert, the truth is I'm just I'm not actually an algebraic geometry pro. But we can look at the proof together. How about that? We can hold hands while we look at the proof. Try it? Okay. I don't even remember the definitions. So projective, I mean, I'm used to thinking about complex varieties, right? Where projective, what, it just is like, I've got compact fibers or something, you know, projective. Implies universally closed. Of what are we dealing? Okay, so silo instead of silo. I don't know. What's the right way to pronounce it? Silo. Let's there should be like a pronunciation, like yeah, of course all just the silo theorems are coming up. Normally there's like you know, language, like how to pronounce names, channels. Oh well. Okay, it doesn't matter. Let's think about, okay. So yeah, Paul Maurice. Okay, but then are we trying to prove this for varieties, for schemes in general? Like, we got to figure out which definition we're using. Projective morphism of schemes. Projective morphisms of schemes. It is projective if X is isomorphic to an S scheme of a closed subscheme of a projective bundle of some quasi-coherent finite type OS module. Is this the definition that we want to use? Proj Pn to spec R will do. I don't know what you mean. Well, you said you don't want the Hartshorne one, right? Yeah, should we use the NLab definition or not? Existence of a closed immersion from X to a projective space. I meant the Proj description of Pn to spec A. Yeah, but I need to know I need to know what definition we're using for projective morphism. Like, okay, that's the case that you want me to do. But okay. So let's use this. So fxy. There's no way we're gonna finish this today, but we can pick it up tomorrow. We can definitely pick it up tomorrow. F to xy is projective if X is isomorphic as an S scheme to a closed subscheme of a projective bundle. If X is isomorphic as an S scheme to a closed subscheme of a projective bundle for a quasi-coherent finite type OS module where E is QCO plus finite type OS module. That's what we're trying to do, Nerdy Quagsire. That's what we're trying to do. All algebraic geometry is an effort to do that. You used to pronounce Serre as Serre. For the longest time. Thank God you heard a Frenchman before you ever spoke at IRL, yeah. CeeLo is probably the correct way, though, if you want to get technical. Okay. Well, I will choose to believe that just because that's the way I already say it. You once said Serre IRL and someone corrected me. Yeah, it do be like that. What drives me nuts is sometimes there's some YouTubers I like and I watch, and then it drives me nuts when they say someone's name like really weird or wrong, and I'm like, you made an hour-long video, a pre-recorded hour-long video. How did you not look this up? I don't know. There's many things you could criticize. There's many things you could probably say in videos, pre-recorded videos I've made that you're like, bro, how didn't you prepare for this? But yeah, names are pretty reasonable to mispronounce. Yeah, that's true. It always boils down to it. I know, but okay. So we're boiling down to that case. Yeah. I believe, but I just wanted to know. Okay, whatever. We're going with this definition. So we'll do this. We'll do this case. So we want F from proj Pn into spec R, and we want to prove it's universally. We want to prove it's universally closed. So let's also check that out. Universally closed. Universally closed morphism. Where was the definition, though? Here's a lemma. In this section, we discuss when a quasi-compact but not necessarily separated morphism is universally closed. But what does universally closed mean? What does it mean? Just give me a definition, bro. Give me a definition. Universally closed morphism. NLab will save the day. After every pullback closed, I see. Right. So F to XY is universally closed if for every Z into Y, the pullback morphism into Z is closed. Okay. So if F is universally closed, then this means that spec R, this means that for every Z, that the pullback proj Pn cross Z over spec R So what this should be the this will be whatever the I don't know, pi z, if pi z is closed, right? Or the pullback, h star f, the induced map here. Okay. You take the fiber of a point in spec R and its intersection with a hypersurface is Pn is null, so it's closed. Looked it up and he's Norwegian, so pronunciation is apparently CeeLo. Okay. Another reason to like algebraic geometry, the words are so poetic. Yeah. Okay. Yeah. Okay. So we'll start with Z. Baby steps. Yeah. I am gonna end stream for today, right away. So now that we know the definitions, we can start tomorrow morning. Trying to prove it. Yeah. But wait, the fiber, you take the fiber over a point in spec R and its intersection with the hypersurface is closed? Proof by ending stream early? Yeah. Well, proof deferred until tomorrow. Technically not left as an exercise to the viewer. Although I would encourage everyone to solve this exercise so you can help me solve it on stream tomorrow. Yep. Okay. So tomorrow we'll do some more algebraic geometry. I'll see y'all then. Go prove some stuff. Go prove this, and we'll come back and we'll prove it together.